Hi, this is Mrs. Anderson. I thought I'd go through this Punnett Square practice worksheet with you just in case you were absent or perhaps you need a little refresher here before our genetics test. So let me go through the problems with you and I'll ask you to pause it so that you can finish filling in your answers for that section and then just resume it when you're ready to continue on to the next section. All right, so for the first section of questions, it says for each genotype below, you're going to indicate whether it's heterozygous. If it's heterozygous, you're going to fill in an HE, or homozygous. If it's homozygous, you put an HO. All right, so that's just to shorten up the writing for you. So this first one is capital A, capital A. So for that, you have to decide to yourself if those alleles match. If they match, they are homozygous. Remember that word part homo means same. So do these match? Big A, big A? Yes, they do. So you're going to write an HO to indicate that that is homozygous. Now the next allele combination is big B, little b. You have to think to yourself, do those alleles match each other? No, they don't in that case. So they are heterozygous. For heterozygous, you put HE. That next one is a letter C, which if you remember in class, I said there's certain letters of the alphabet that are hard for doing Punnett squares. C is one of those. It's really difficult to tell between upper and lower cases. But in this case, it's a little bit easier to see just because they're right next to each other. So we have a big C and a little c. All right, those do not match. So those alleles don't match. Maybe your mother gave you a big C and your father gave you a little c. So either way, whoever gave you what, this allele combination represents heterozygous. So we're going to put HE. All right, the middle column, big E, little e, they don't match. They must be heterozygous. Little f, those do match, so those are homozygous, HO. Big G, little g, those are heterozygous. All right, go ahead and pause the video and fill in the rest of that section. Now we're going to move on to the second section. We are looking at genotypes that have been given to us. Now we have to determine what the phenotype would be. Genotype is the genes, the actual genes. In our class, we use letters of the alphabet to represent the genes. And phenotype would be the physical characteristics, so the color, the length of something, lots of different attributes for the phenotypes. In this first question, it tells us that purple flowers are dominant to white flowers. So remember, dominant, that means it's going to take over and show. If it's at all present, the only time we're not going to see the dominant attribute showing, which is purple flowers, is if there's no dominant alleles around. It's only recessive alleles. So let's take a look at our choices here. We've got big P, big P. So as long as it has at least one big letter, it's going to show the dominant trait. In this case, that means purple flowers. Our next one is big P, little p. And again, we at least have this one big P. So that's going to show purple flowers. Even though we do have that little p in its genes, it's going to get hidden by the dominant attribute. That last genotype is little p. So in that case, if they're both recessive, then the recessive thing gets a chance to rise and shine. So in this case, that means white flowers. All right, go ahead and pause the video. Try the rest in section 2. All right, moving along. We've got section 3 for the phenotype. Now we're going to list the genotype. All right, so we have the physical attributes given. Now we have to figure out the allele combinations to give us those looks. So straight hair is dominant to curly hair. You might be tempted to do an S for this question, S for straight. Try not to use S's. Those are difficult to see the difference between the upper and lower case. So here we have straight hair. We would need at least one large letter. So here I'm going to use the letter H. Okay, so straight hair is dominant. I'm going to put a big H there. Curly, I'm going to give that a little H. So an allele combination to give us straight hair would be if we had two dominants. Two big H's would give us straight hair. And another combination would be a big H and a little h. That would still give you straight hair. That big H would take over. The only allele combination that's possible to give you the recessive look would be little letters. So little letter, little letter. In that case, it was H. Go ahead and pause the video. Try the next one. Okay, moving on to the final section of this page. We're going to set up Punnett squares for these crosses. Now your worksheet says a very critical piece of information right here, that round seeds are dominant to wrinkled seeds. All right, so that means the round seed gets the big R, and a wrinkled seed then would get a little r. Okay, so now let's take a look at our Punnett squares. These are kind of like trading wheels. You won't always be provided with a box and with the genotypes of the parents, but while we're starting off nice and easy, they're given to you. So this is one parent's allele combination, and this is the other parent's allele combination. Okay, remember they're always in pairs. That is because you received one from your mother and one from your father. Those alleles separate whenever your body is going through meiosis to make your gametes. And then they join back up in the process of fertilization. So you'll always have a diploid number, a 2 set for the alleles. So now what we need to do here is make sure that we are paying careful attention. We're going to take the alleles for one parent, place them on the side, the alleles for the other parent, and place them on the top. If you reverse those, it really doesn't matter, you get the same answer, as long as you keep them on the same side. So I'm going to take that first parent, big R, little r. I'm going to put one allele next to these boxes, the other allele next to these boxes. Then I'm going to take the other parent, is little r, little r. I'm going to put one little r above that column of boxes, the other little r there on top of that column of boxes. Now what you do is you're going to fill in these alleles to where they meet in each box. So this big R will get pulled over into each of the boxes it is next to. So you drop one there, you drop one right there. And this little r comes over, fills in the boxes it is next to, just like that. The letter on the top gets dropped down into the boxes below it. And on the right side. Okay, so the filling in part is very simple. It's just a way to organize your answers here. Okay, now we have to go back to the question, figure out what it's asking us. It says, what % of the offspring will be round? Now remember, to be round, it has to have at least one big letter. Okay, because we said round are dominant, so it gets the big letter. Now we have to take a look at what we have in our 4 possible offsprings for this cross. And we see that 2 boxes have big R. So that means we've got 50%. Okay, 50% would be round. Now, just a reminder, each of those 4 boxes represents 25%. If you are not a percent person, you could do fraction, 1/4, 2/4, 3/4, 4/4, Or if you're a money person, you like money, you can always think of quarters. So 25 cents, 50 cents, 75 cents, and $1. All right, go ahead and pause the video, try the remaining questions, and please ask for help in class if you need it.